This lesson will focus on how to solve problems that have a bunch of radicals in them. And what you need to be aware of is that whenever you have problems that have radicals in them, square root symbols, cube roots, fourth roots, whatever, it doesn't matter. Whenever that happens, you need to check for what are called extraneous roots. Extraneous roots are things where they look like a solution when you solve that algebraically, but then when you go to check your answer and plug it into the problem, it ends up not working. And you will get lots of extraneous roots whenever you have problems with radicals. And I'll show you some examples so you know what I mean better. Okay, so here's my first example where I'm wanting you to find the cube root of x minus 3 equals 3 and find a solution to that. And what you need to know is you may also see that problem written like this, just so you know. It is the same exact thing because the cube root of something is taking this, it's the same thing as taking it to the 1/3 power. Either way you do that, what you want to do is you want to undo that cube root symbol. I'm just going to move this over here. You want to undo that cube root symbol by doing the opposite of it, which would be to cube it. Okay, and what you do to one side, you have to do to the other. In this case, I would take it to cube it, I would take it to the 3 times 1, and it's undone then. Okay, so either way, the cube undoes the cube root, and I just have x minus 3 equals 3 cubed, which is 27. And then, of course, I can add the 3 to it, and I get x equals 30. Now, before you know that it's a solution, you really do have to check it. So I am going to go ahead and plug this 30 back into my original problem, and I am going to check it. So my question is the cube root of 30 minus 3 equal to 3? Well, 30 minus 3 is 27, and the cube root of 27 is 3, and so, ta-da, it checks, and x equals 30 really and truly is a solution. Okay, here you've got a little bit different setup because what's underneath the radical is not isolated. So in order to solve these problems, you have to take what's underneath the radical first and isolate them. So in other words, I want this piece of it on one side of the equation first before I start to square anything. So I will not square it until I have that by itself. So I need to subtract 9, okay? And then I will have the square root of x minus 8 equals 8 minus 9 is negative 1. Now I have the piece that's underneath the radical isolated or by itself on one side of the equal sign. So I'm going to get rid of it by doing the opposite. So the opposite of a square root would be to square something. And so when you square the square root, they undo each other, and I just have x minus 8. And then negative 1 squared means negative 1 times negative 1, which is 1. And I will add 8. And it looks to me like x is supposed to be 9. But again, before you think it is, we need to check it. So I'm going to take this 9 and I'm going to plug it all the way back up into my original equation and check it. So I have to decide, is the square root of 9 minus 8 plus 9 equal to 8? Well, the square root of 1 plus 9, the square root of 1 is 1, and 1 plus 9 does not equal 8. So this problem didn't check, and so this, because it doesn't check, it actually doesn't have a solution. And so my answer should be no solution. X equals 9 then would be what's called an extraneous root. It looks like it works, but when you plug it in to check it, it doesn't work. Okay, here's another one that I'll just give you a hint. I can tell you right now that this will end up in an extraneous root because there is absolutely no number that I can take the square root of and get a negative answer. So I will tell you right now that this will have no solution and you'll get extraneous roots, but let's check it, okay? So I will square both sides because the part that's underneath the radical is isolated already. I've got that on one side of its equation by itself, okay? And so then this will undo each other, and so I will have x plus 4 equals negative 6 squared is 36. Subtract 4, and I get x equals 32. So it looks like it has a solution. I'll go ahead and plug it back in. the square root of 32 plus 4 is supposed to equal negative 6. Well, the square root of 36 doesn't equal negative 6. The square root of 36 is 6, and it doesn't equal negative 6. So that's how you get an extraneous root. And again, this one has no solution. All right, and then lastly, now I've got radicals on both sides, so I will still square both sides like that, okay? And now I will have 6x minus 4 because these undo each other and these undo each other. So I will have 6x minus 4 equals 5x plus 2. And I will solve that by subtracting 5x. So I have x minus 4 equals 2. Add the 4 over, and x should be 6. So again, we need to check that. Whenever you have radicals, you have to check. So when I plug this back in, my question is does the square root of 6 times 6 minus 4 equal the square root of 5 times 6 plus 2? So 6 times 6 is 36, minus 4 is the square root of 32. 5 times 6 is 30, plus 2 is the square root of 32. And both sides are equal. I could certainly get decimal values for them if I wanted, but I can see that they're equal. So x equals 6 is a solution. And then I'm just going to tell you something that every once in a while will pop up in your accelerated math, and that is you will get a problem that looks maybe something like this. I don't know, I'm just sort of making this up. And remember how I said you can't square each side unless you can isolate the radical? Well, I can't do anything. There's nothing more that I can simplify when I do this problem. So I do have to square both sides. And I will tell you that when I square this left side, it doesn't just, I mean, it will get rid of the radical, but squaring the left side really means that you have to take x minus 3 times the square root of x minus 3 like that. The right side will get rid of the radical, just so you know. And then you're going to have to simplify and do that again. And I don't know if that comes up real often, but if it does, that is how you handle that, okay?